quickly, physical characteristics, physical properties can be measured without changing the substance around. So there are two kinds, intensive and extensive. Okay, so rusting, any kind of rusting is considered a chemical property. Flammability, again, chemical property. Now we're going to talk about the changes. So what does that mean? That means you're carrying out some kind of change. And is it physical or is it chemical? So if I'm cutting something, obviously that's a physical change. If we're grinding something down, you're melting something, you're freezing something, dissolving, all of these are considered physical changes. Why? Because the substance that you end up with is the same that you started with. The shape changed, maybe the color changed, maybe, the size changed, the state of matter changed, but the actual material, the compound, the element, whatever you're dealing with, did not change. On the other hand, if I'm talking about chemical changes, it's a complete different substance than I started with. If I burn a match, now it's no longer that match, right? It's not reversible. I can't reuse that match anymore. It's done, it's burnt. If something is tarnished, I have to carry out another chemical reaction to change it back. If it's reacting with water, something like this, bless you, such as this is sodium metal that gives off that yellow spark, you don't have that sodium metal anymore. Now it's a sodium hydroxide solution. When it's rotting away, that means it's really little organisms, microorganisms, right? Breaking the large molecules into smaller, so it's a chemical reaction. So we're going to do a bunch of these. We're going to practice. Okay. So melting ice, physical or chemical? Physical. Why?
Material
Stays the same. All right. Digesting an apple. Chemical. Is it still an apple? No, that's it. It's done with. Reactivity with water. Chemical. Dissolving salt in water. Physical. Why? It's still salt. It's still water. Remember we talked about yesterday, if we were to separate them, we just have to heat it up to separate it.
Water becomes salt water?
Yeah. But can you separate the salt from the water?
So it doesn't, if you can reverse it, that also is.
Yes.
Okay.
Yes, it helps with density. What do we consider that? Physical. Do we consider that intensive or extensive?
Extensive.
Intensive or extensive?
Oh,
intensive. Density. Like, for example, water has a density of 1. It's always 1 no matter how much water you have. Fermentation? Yes. Sure. When we're talking about intensive properties, it does not matter on how much of the material you have. So, water boils at 100 degrees Celsius. It doesn't matter whether I have a cup of water or an entire pot of water. It's still going to boil at 100 degrees. We call that intensive. It's dependent on its composition more than how much of it you have. If I'm taking the mass of something, that's extensive, right? If I'm pouring out 100 milliliters versus 2 milliliters, there's a difference in the amount of matter, then it becomes extensive. Okay, got it? All right, boiling point, physical. Flammability, is chemical property. Malleability, physical, right? If something is malleable and you can measure the malleability without having to change it, it's still the same. You just change the physical, but not the actual component, what it's made up of. All right, now density is mass over volume. How much of it you have per unit area. Mass can be measured in grams, kilograms, milligrams, any gram units. Volume can be measured in either cubic meters, cubic centimeters, any cubic unit, or milliliter, liter, and so on. The conversion factor in terms of what is 1 milliliter is equal to 1 centimeter cube. What that means is if I make a little cube that measures 1 by 1 by 1, so if it's a 1, 1, and a 1, I can pour in here 1 milliliter of water, or 1 milliliter of any water. That's the idea behind it, that if it was 1 by 1 by 1, 1 centimeter each side, it would take up 1 milliliter of volume. So that's why we use volume is either length times width times height, right? Which gives me cubed units, centimeter cube, millimeter cube, whatever. Or you have volume. So if I'm measuring liquid, I can just measure in a graduated cylinder. But if I'm measuring a solid cube, then obviously I'm measuring it by length times width times height.
Then how is it density extensive? It's like it'll change depends on like the matter.
Mm-mm. Everything has its own density. Why? Because it's gram per volume. So if I have a lot more volume, I would have a lot more mass, right? For that substance that has a certain amount of mass per unit volume. Mm-hmm. All right, so density can be used as a property. But what is it? Right? What does it mean for something to be dense? That means there's a lot of mass per unit volume. Okay? So more mass, right, would give you greater density if you don't change volume. So if you're measuring two things and, I don't know, you're measuring the density of air, that's going to be really low versus the density of, let's say, a gold bar, right? So you have to also think about how is matter actually organized. When we talked about the states of matter, right, we saw solid was very close, but gases were all over the place. So gases have very low density compared to solids. Now, here's a question. It says, what does the density actually depend on? And so which of these samples has more mass? Assume each particle has the same size and mass and is uniformly distributed. Which one is more massive? A, right? Because you have more of these particles. Now, yes, A is more massive, but if you had to figure out density, you're going to have to divide by volume, right? So, which one has more volume? A takes up more space. Okay? So, if I compare these, maybe they have the same density. I can't really do a perfect comparison unless I know the real numbers. But if I compare B and C, which one has more density? C. Okay? So because I have more mass per same unit volume as that. So it's dependent upon mass and volume. Okay? All right. So it says, imagine now sample A is styrofoam and sample B is brick. Which one do you think will be more dense?
What's brick?
B. Yeah, right? That makes sense. Now, the formula we're going to use for density is mass over volume. And the units are going to be gram per centimeter cube or gram per milliliter if we're talking about liquids and gases. So let's do a sample problem so we know how this goes. All right. So you have a sample of copper. Copper has a mass of 9.4 grams, this little sample, and is measured to be 3.5 centimeter cube. How would you calculate density of copper? First, by the way, you have to show your work in everything you do, just like math. You put the formula, okay? You put the given information. All right, mass is 9.4 grams. Volume is 3.5 centimeter cube. Then you plug in. And then you get your answer, which is going to be what, 2 point something? Whatever. You can do that on your calculator, centimeter cube. You have to make sure to put units. Numbers are going to be meaningless without them. Yes?
What happens on the places you have a calculator like this?
Yeah, of course. Okay, there's something off there. All right. So, you can manipulate the formula, right? You know how to calculate volume if you're given density and mass. You know how to calculate mass if you're given density and volume, correct?
Mhm.
Yeah. Algebra 1. All of you have that. Okay. You know. Okay. So let's do this. Density of silver is 10.5 grams per centimeter cube. What mass is a sample of silver that has a volume of 14.5? Well, you know D equals M over V, right? You can manipulate from the beginning, or you can plug in and solve for the missing variable. However you're comfortable with it, makes zero difference to me. So 10.5 grams per centimeter cube is equal to X, which is your M, over 14.5 centimeter cube. You're going to cross multiply those, right? And mass is going to be something incorrect. Okay? 152. All right. So go ahead and try this one on your own. I'm pretty sure you can do this within a minute. You have a mass of carbon tetrachloride that's given to you. Density is given to you, and you're looking for volume. All right. Go ahead. Come on. This should take like a minute. Let's go. Let's go. Let's go, people. What's the answer?
35.2 divided by 1.6.
Okay, where's your calculator? Oh, Miss H.
Oh, you actually want it?
Come on, bro.
You actually want it?
Yeah, no.
But, like, I know what it
I
is.
told you to solve it
Just for funsies, you know?
Yeah, yep.
22.
No.
2.0. 22.
Just 22? No.
Wait a minute. So if we're looking for volume, right, D equals M over V, and I'm solving for V, yes?
Yeah.
Okay.
What is it, 22? Look at that.
Look at that. How about if we have a problem where we have to calculate volume first because, geometry 101. Come on. D equals length times width times height. And then you have a mass. You know how to do this too, right? It's just simple math. I'm not going to spend all this time on it. Okay.
We should do the lab where you put all the different substances and make a rainbow based on density. I did that in 8th grade.
It's so messy.
It's so fun though.
It is fun. It's a good one actually to visualize. All right, 3.85. How about if I have kilograms? What do I know about the kilogram to gram conversion? 1,000. Which way?
More.
Right, so kilogram is a large unit, right? If I'm going to convert it to grams, I'm going to end up with 1,000 of that. So it's going to be 3,850 grams divided by the 275, which is the volume. All right. Okay.
Partner challenge.
Partner challenge. What do you know? Okay, let's go. Find a partner, work out the problem, and then come up and do it. Let's go.
Wait, Taylor loves 10.
Come on.
Oh, this is
You
so
got
easy.
this.
Okay, 25 times 35 times 50. Volume is 43,750. Density by the mass, so mass equals density times volume. So that times 7.31 equals.
Wait.
Oh, it's millimeters.
It's what?
The math always has to be in grams, right?
It's in millimeters, so I have to put it over 3 times. So it's 1, 2, 3. So it's 319.8.
All right, what's the answer?
319.8? Question mark, question mark? I'm kind of just making it up as I go.
How many millimeters are in a centimeter? We should know this.
Milla.
No. Meter to millimeter is 1,000.
Oh, it's 100?
No, it's a 10.
10,000? So I have to put it over 4 times? 1, 2, 3, 4. So it's 30.